Hello, a very good morning, students. Gautam, good morning. Ayush, good morning. Asmita, good morning. Tarun, very good morning. Tanya, good morning. How are you all guys? Huh? Fine? Fine? Fine. So, what is our today's topic? Today we'll be revising sequence and series. Okay? Okay. Jatin Raj, a very good morning. I'm very fine. I'm pretty fine. So, here at Careers 360, because of the lockdown, we have devised a mega revision marathon and we have created a series of lectures, online lectures. Ayush, I'm fine. We've created a series of lectures for JEE Main 2020 aspirants. So, our small effort, whatever efforts we are doing, will help you in your POA. Okay, so we start with sequence and series. So first we go to, yes, Vipul Raj, hello, Shekhar Raja, good morning. Yeah, 22nd June. Yeah, somewhere around that. Okay, yeah. So we first of all come to the definition of sequence. A sequence is a list of things, usually numbers that are in order. Okay, so that's a sequence. So like Fibonacci sequence or etc. Like series. If we add or subtract all the terms of a sequence, we'll get an expression which is called arithmetical expression, which is called a series. Sumit, good morning. Tanya, good morning. Giridhar Sunil, good morning. Mala Jaswal, very good morning. So, when do we get a series? When we separate the terms by plus or minus sign of a sequence, then we get a series. Then what is the difference of a progression? Ankita Yadav, good morning. If the terms of a sequence is increasing or decreasing numerically, then it is defined as progression. I mean, here there is a slight change. That is, progression will be, a sequence in which nth term can be defined. I mean, there is a regular pattern. Okay, that would be a progression where an nth term can also be defined. That would be known as a progression, like an AP or a GP. Okay, so we start with AP. Yes, it is important for advance also, Shekhar. It is important, but rather it is more important for JEE mains than the advanced portion. Okay, but so far as advance is concerned, we cannot say which portion is important, which portion is not important. But so far as sequence and series is concerned, we will say that sequence and series is comparatively more important to for JEE mains. Okay. Now, arithmetic progression. It is a sequence in which consecutive terms have a common difference. Okay. So this we'll quickly go through. Then general term of an AP. The general term of an AP is A plus n minus 1D. What is A? Is the first term and n is the term which you want to find and D is the common difference. Okay. Now, important properties of an AP. If a fixed number is added or subtracted, each term of a given AP, then the resulting series is also an AP. Okay. And the common difference remains same. So obviously, if you add or subtract each term of an AP by a fixed number, then the resulting series is also an AP and its common difference remains the same. Okay? Then, if each term of an AP is multiplied by a fixed constant or divided by a non-zero, please realize non-zero fixed constant, then the resulting series is also an AP and the common difference respectively get divided or multiplied or divided by the constant by which we are multiplying or divide. Okay. Then if A1, A2, A3 and B1, B2, B3 are two APs, then if we add subtract the respective terms, the series is still an AP. Okay. So we go to the next slide. Uh, Three terms to be selected in AP would be like what? A minus D, A and A plus D. A minus D, A and A plus D. And four terms to be selected are A minus 3D, A minus D, A plus D, A plus 2D. 3D. You realize that the common difference here is 2D. Okay, the first term here is A minus D. So never misunderstand it. The first term here is A minus D. A is not the first term here. A is not the first term here. Okay. Moreover, these terms are to be only supposed when the sum of the terms is given. Okay. When the sum of the terms is given, then only we'll assume like this. Then A1, A2, A3, AN are in AP. Then the terms equidistant from beginning and end, the sum of the terms equidistant from beginning and end are equal. So this is the first term from the beginning, this is the last term from the end. That is the second term from the beginning, that's the second last term from the end. This is the third term from the beginning, this is the third last term from the end. So they all are equal. Rth term from the beginning and Rth term from the end, they all are equal. Okay. Then if A1, A2, A3, AN are in AP, then AR, Rth term is AR minus K, AR plus K divided by 2. Okay. Provided K lies between N minus R, because if you add N minus R, it should be, if you put K here, then N should, N and here 1 should come. So that's why. Okay. So obviously, next, sum of N terms of Ayush, in multiplication case also we can use first point. Which point you are referring to? Yes, Meenakshi, good morning. No problem, you are a little late. Join us. No, you are not too late. Then, Ayush, what you are referring to? Can you be more elaborate? Previous slide. Okay, I go to the previous slide. You refer to it. If a fixed number is added or subtracted, if each term is, yeah, this one you are referring to. Okay. So if each term of an AP is multiplied, first point you are saying, if a fixed number is added or subtracted to each term of a given AP, then the resulting series is also an AP. Okay. I hope you all understand this. So sum of n terms of an AP. So here we have a formula. Everybody is aware of that, but still let's revise it. N by 2, 2a, this we'll write it as 2a plus n minus 1d, and when we'll write it, this would be the first term, this would become the last term. So this is the other formula. A becomes first term and L becomes last term. And there is another formula for Sn, that is, you write the nth term and then rth term, and then from r is equal to 1 sigma you can use. Okay, that's how you can write. Ayush, a minus d, a plus d. Yeah. In multiplication case also we can use first point. Acha, now you want to say that if the multiplication of the terms is given, then we can still choose a minus d, a and a plus d. You are right, Ayush. We can use this point. Okay. So this formula is also used. So we write the rth term of the sequence and then we use the summation. Okay, summation formula. Okay. Hello Ashit Shikhar. Good morning. So this is the sum to n terms of an AP. Then, okay, We'll do one or two question. Arithmetic mean. Before we start with arithmetic mean, can you do one question, students? And before I start with the arithmetic mean and the arithmetic mean, there is x, greatest integer of x, and fractional part of x. Okay, x, greatest integer of x, and fractional part of x are in AP. Then number of integral values of x, number of integral values of x satisfying it. So let's see how many of you get it right. They are in AP. X, greatest integer of x, and fractional part of x are in AP. Then the number of integral values of x satisfying it. Can somebody answer me? Senthil, a very good morning. I'm wonderful. I hope the same for you, Senthil. So, how do you do this? Yes? I'm waiting for an answer. X, greatest integer of x, and fractional part of x are in AP. Then the number of integral values of x satisfying it. I hope everybody is aware of what is the greatest integer function, what's a fractional part function. Although we haven't revised it, but I sincerely hope that you guys are very well aware of greatest integer of a function and fractional part of a function. So I think nobody is giving me an answer. So I'll go ahead with the solution myself. You see, Abhimanyu Gupta, even number. No, I don't get. All even number. No, not at all. No, Abhimanyu Gupta. So we have greatest integer of x minus x, is equal to fractional part of x minus greatest integer x. Am I right? Now, isn't this the definition of fractional part function? This would be minus fractional part. This would be fractional part. This would be minus x. Because we have fractional part of x equal to x minus greatest integer. If we subtract greatest integer from the number itself, we get the decimal part of it. Okay? So this is fractional part of x. Okay? So it goes on the right hand side and gent of x goes on the left hand side. Greatest integer x here and it becomes twice of fractional part of x. Am I right? Now, the term left hand side is an integer. Am I right? And the term on the right hand side, fraction part of x, when we look at it, it's a fraction. So 2 into a fraction. Am I right? Now, the fractional part of x, no matter what, it will range from 0 to 1. Whatever x you may feed in. So here, what best integer you can get? If you get an output from fractional part of x as a value between 0 and 1, so unless fractional part of x is half, this 2 into half is never going to give you an integer. Okay? Hello? So I get 1. That is, and then otherwise fractional part of x is 0. We get 0. So when we get 0, so 2 into 0 will become, here it would become 1, here it would become 0. These are the two integers which we can get on the right hand side. Do you all agree? This is the integer we can only get on the right hand side, that is 1 and 0 itself. So when we put a value 0 here, so what is the greatest integer here I'll get? I'll get 0 and here I'll get 2 into 0, so that is 0 itself. Am I right? But at the same time, number of integral values we are supposed to find satisfying it. So 0 of course is an answer, but at the same time, if I take x as 3 by 2, am I right? If x is 3 by 2, Then greatest integer of x would be what? Tell me. Greatest integer of x would be 1. And fractional part of x would be half. 2 into half. So that's also equal to 1. So 3 by 2, x equal to 3 by 2 also satisfies. But then 3 by 2 is not an integer. Am I right or wrong? Tell me. Hello? The x equal to 3 by 2 is not an integer. Am I right or wrong? है ना? So only 0 will satisfy it. Only 0. So only one value will satisfy it. Or if you want to find out the roots of the equation, then 3 by 2 will satisfy it. If number of integral values is not asked, only the values of x is asked, then x equal to 3 by 2 is there. Okay? Hello Mona Lisa. Good morning. So x equal to 3 by 2 is one of the answers, 0 is one of the answer, but number of integral values is being asked, so it is 0 only. I hope you understood it. Okay, now I'll make use of this slide once again for, after erasing it, I'll make use of the slide for arithmetic mean. That is what we were supposed to think. Is it okay? 3 by 2. Yes, Meenakshi, why not? When 3 by 2 is there, the greatest integer value will be 1. While 3 by 2, the fractional part would be half. Half into 2 will give you 1. So both sides 1 would satisfy. है ना? Array, 3 by 2 fractional part is what? Half. Half into 2 is what? 1. That is on the right hand side we get. And 3 by 2 greatest integer part, what we'll get? 1. So 1 will be equal to 1. Am I right? Yes, Meenakshi? Ayush, are you satisfied? I hope I have answered your question. Hello? Yes, okay. Akshay Shikhar. How many questions teached Deepak, sorry. This was the first question we took, beta. This was the first question. So no worries. We go to the next. That is arithmetic mean. Theoretical portions mostly we'll be discussing. So okay. We move on to the next. Nice question. Thank you, Ayush. So arithmetic mean. Here I'll teach you three things. Number one, if arithmetic mean between a and x and y, okay, that's equal to x plus y by 2. Am I right? This is the arithmetic mean between x and y. Similarly, here we'll like to compare with if ABC are in AP. If ABC are in AP, then B is equal to A plus C by 2. Am I right or wrong? Tell me. Then if I compare this and this, arithmetic mean of x, y and B, then I would realize that B is nothing but the arithmetic mean between A and C. Okay? Between A and C. Right? Then second, arithmetic mean between n numbers. Between n numbers. So arithmetic mean between n numbers, it would be numbers are, let us say, x1, x2, x3 and so on. Okay. The arithmetic mean is given by x1 plus x2 plus x3 and so on till xn divided by n. That is the arithmetic mean between n numbers. Okay. You want me, Ashikhar, theory part less while questions more. Okay, let's see. Theory is ultimately less in sequence and series. So third part would be inserting of, you see we are finishing with arithmetic progression. Inserting of n arithmetic means between two given numbers. Okay. Two given numbers are A and B, and we want to insert n arithmetic means between them. So how do we do that? So here we have, let's say, A and B. First of all, what is the meaning of this inserting of an arithmetic means? Arithmetic means, let's say, are numbers A1, A2, A3 and so on till AN. So these are the Tarun. Tomorrow there will be a test of this chapter. Yes, first of all we will practice and then there will be a test. A1 to AN, these are the arithmetic means. And it means that after insertion of these numbers, this is given, this is given. After insertion of these numbers, this should become an AP. Am I right? So B is the n plus 2th term of the sequence. Let's say D is the common difference. So A plus n plus 2 minus 1 D. Am I right? This would imply D is B minus A upon n plus 1. This common difference you should remember always. Okay? D is equal to B minus A upon n plus 1. So this is the common difference which you get. Then A1 would be what? A plus D, that is the second term of the sequence. A2 would be what? A plus 2D. And similarly, AN would be what? Nth arithmetic mean would be A plus ND. Am I right? That's how we take the arithmetic means. That's how we find the arithmetic means between two given numbers. Okay? Now, sum of n arithmetic means between two numbers is n times the single arithmetic mean. Let's see how do we get this. So you have to find basically A1 plus A2 plus A3 and so on till AN minus 1 plus AN. That is what is equal to. That's what you are interested in. Now since these numbers are in AP, the sum would be n by 2 first term plus last term. This would be the sum to n arithmetic means. But considering that A1, A2 and so on till AN minus 1, AN, B are in AP. These were initially in AP. So the sum of first and last term is equal to sum of second term and second last term. Isn't that right? So this way A1 plus AN can be replaced by A plus B. So this is what we'll get. Arithmetic mean between two numbers is n times the single arithmetic mean between them. Okay? So n times the single arithmetic mean between them. This is the single arithmetic mean between A and B. Okay? So that's how we get it. Then let us say we come to now geometric progression. Geometric progression. A geometric sequence is a sequence where the first term is non-zero, okay, and the ratio between consecutive terms is always the same constant. The constant factor is called the common ratio and denoted by R. Just Tarun, let's study maths first, then we'll talk about chemistry and physics class. Yes, Tarun? So, a geometric sequence, everybody understands geometric sequence, that the consecutive terms they are in the same ratio. A2 by A1, that's the following term divided by the preceding term gives you a ratio, that is R. So the general terms gives you ARN minus 1. Okay. Now let us quickly go through GP. We have an increasing or decreasing GP. Okay. Then we have important properties of GP. Let's quickly go through. If each term of a GP is multiplied by a fixed constant or divided by a non-zero fixed constant, then the resulting series is also a GP. So if we multiply or divide by a non-zero fixed constant, the resulting series is also a GP. Okay? Yes, HP is there, beta Meenakshi. HP would be there. Okay? Statistics and mathematical reasoning. Let's see, Ayush, there would be a class on statistics as well as mathematical reasoning. Okay. Yeah, it's there in JEE syllabus. Yes, Sanskriti, it's there in JEE syllabus. And second point, if A1, A2, A3 and B1, B2, B3, etc. are two GPs, then if we multiply the respective terms or divide the respective terms, they are still in GP. Okay? So please focus on these properties, although you know them, but still go through them. That would be helpful for you guys. Okay? Then we have, if A1, A2, A3 are in GP and common ratio R, then the first and last term product, second term and second last term product, third term and third last term product is equal. Okay? So that means product of the terms equidistant from beginning and end are equal. Okay? And this way I can write AR minus K into AR plus K. And if we raise to the power, if we take raise to the power of the respective GP terms, raised to the power of a sum constant, then it is still a GP with common ratio R and n belongs to rational number. Okay. Then if A1, A2, A3, An minus 1, An are in GP with common ratio R, then log of A1, log of A2, log of A3 are in AP, and converse also holds true. Okay. Corona fighters, you are speaking of first point, please. First point on this slide, beta. First point on this slide. You mean this one? Okay, this is product of the terms equidistant from beginning and end are equal. Okay. So for example, if you want me to exemplify it, then I'll exemplify also. Let's say 3, 6, 12, 24, 48 and 96. These are the terms in GP. Okay. Now if I take the first term and last term, if I take the product, what that would be? If I take the product of it, so that would be 300 minus 12, that is 288. If I take the product of 6 and 48, it would again be 288. If I take the product of third term and third last term, it would still be 288. That's what it means. Okay. Product of the terms equidistant from beginning and end are equal. Okay, students. So we have geometric mean now. Okay. Now geometric mean, I'll quickly go through geometric mean. Again, I'm going to tell you three things in geometric mean. If x and y are positive real numbers, then geometric mean between x and y is given by under root xy. Okay. Now here, once again, we have if ABC are in GP. If ABC are in GP, then B is equal to under root AC, provided ABC are positive. Okay. B is equal to under root AC. So if I compare this, then what do I get? I have B is the geometric mean between A and C. Between A and C. Okay. That's what we have. Then second, geometric mean between n terms, geometric mean between n numbers. So let's say n terms are x1, x2, x3 and they are all positive. Okay. They are all positive numbers, n terms which are positive, n positive terms. Okay. Sheila Prasad, when will mains be? Approximately in the last or second last week of June. That's what we presume as of now. But who knows? Okay, so the geometric mean would be given by, these are not in GP. Yes, I'm telling you, these may not be in GP, but these are positive numbers only. So we'll multiply these numbers, x1, x2, x3, and so on, xn raised to power 1 by n. That would would be the geometric mean between these numbers. Is it okay? Now, third, inserting of n geometric means. Yeah, June only. June only there would be an exam, not May. Who knows JEE Advanced would be there or not? Maybe it might get cancelled. I'm not pretty sure of that. There is no instruction regarding this. Okay, here we have third point, inserting of n geometric means between two given numbers. Okay, two given numbers. So what's that? Acha, today news only. Ayush, okay, it won't be cancelled. Wow. So A and B, we have n geometric means. Okay, I didn't see the today news. So till GN, these are the geometric means which I have inserted. So ultimately after insertion of these numbers, this will become a GP. That's what it is. Okay, yes. Good only, because advanced would separate the very best amongst the students. Okay. So B is the n plus 2th term of this sequence because these are n plus 2 terms. So A, let the common ratio be R, it would be n plus 1. And n plus 2 minus 1. July 12th, JEE Advanced expected. Okay, Satvik, ready? So we have from here R is equal to B by A raised to power 1 upon n plus 1. Okay, that's how we get R. And G1 would be the second term of the sequence, that is AR. G2 would be AR square, and so on. We'll have Gn equal to AR raised to power n. Okay. Now, like in arithmetic mean, we have sum of arithmetic means. In geometric mean, we have product of all the geometric means. And let's see what the product of all geometric means is. So let's see what I'm interested in. I'm interested in finding G1, G2, G3 and so on till Gn. What is this product equal to? According to the statement, it is equal to the nth power of geometric mean between A and B. The geometric mean between A and B is under root AB. And nth power would be this. This should be equal to this. Let's see whether it is this or not. Okay. Yes, Asta Agarwal. Hello. Asta Agarwal. Nahi, career 360 only. So we have Prashant, hello. So we have to take the product of these numbers. So in a GP we know the first term and the last term couples up. The second term and the second last term couples up. This way, how many couples I will be able to make? N by 2 couples. Because these are n numbers, so n by 2 couplings I can make. Okay. Good morning, Prashant. Now, we realize this is the second term and second last term of a GP. So this can be replaced by AB. This can be replaced by AB. So every pair can be replaced by A into B, the first term into the last term. So how many terms are these? N by 2. So I'll have this n by 2 terms. So what I'll get? AB into AB into AB and so on. So I'll get AB raised to power n by 2. That's nothing but under root AB. That's the single geometric mean between AB raised to power n. Am I right? That's what we get. So GP also we have done. Let's see one or two questions here. By the way, if A and G are the arithmetic mean and geometric mean of A and B, okay, we have certain relations. Two real positive distinct numbers, then A and B are the roots of the equation. I hope this is understood. A and B are the roots of the equation x square minus 2ax plus g square, and A and B are given by a plus minus under root a plus g under root a minus g. That's what is a reduced question. In fact, there's a question in itself and it has been reduced into a result. Okay. Then, so sum to n terms of a GP. Sum to n terms of a GP. What is that? Sn is equal to a r raised to power n minus 1 r minus 1. This as well, this we generally use when r is greater than 1. When r is less than 1, we make use of this formula. R is less than 1, we make use of this formula. Sum of an infinite GP a upon 1 minus r, but when mod of r is less than 1. This implies r is a proper fraction between minus 1 and 1. Okay. This is sum to infinite GP. Then the value of 0.3585 is, can you find it, students? What's the value of this? This would be, so one way which you have learned quite earlier in your life, I don't want to go with that way. That is, if you multiply it by 10 or 1000 or 10,000 and then you subtract it, that way I don't want to go. So I'll write it 0.35 plus 85 into 10 raised to power minus 4, then 85 into 10 raised to power minus 6. I can write like this number, 85 into 10 raised to power minus 8, and so on. This goes on till infinity. Okay, students? So we have 0.35 means 35 upon 100. What is this? 85. And this is a GP, 10 raised to power minus 4, 10 raised to power minus 6, 10 raised to power minus 8, and this is an infinite GP. The first term being 10 raised to power minus 4, the common ratio being 10 raised to power minus 2. That's it. So what do we get here? We get 35 upon 100 plus 85, and this is 10 raised to power minus 4, that would be 1 by 10,000 upon 1 by 100, so this would give me 99 by 100. Am I right? So this 00 and 00 would be cancelled. What do I get? I get 35 by 100 plus 85 by 9900. Am I right? Yes, students? And this can be calculated. I'm not going into the nitty-gritties of the calculation. Okay, this would be, when we say the value of this, they want to mean it actually means that we want to express it as a fraction. Okay, so this is it. Then let's see what we have here. The sum of n terms of an AP. This is a very old problem. How do we do this? Yes, students, any idea? What will we do? A is a natural number where A ranges from 1 to 9. So suppose it is 7, 0.7 plus 0.77, 0.77, and then we will replace 7 by A. This is, so what we'll do, we'll take 7 as common. So what do we get? 0.1, 0.11, 0.111, and so on. This we'll multiply and divide by 9. So we'll get 7 by 9. And here 0.9, 0.99, and so on, 0.999. Okay, this goes on. Okay, yeah, multiply and divide by 9. So what do we get? 7 by 9. 0.9 can be written as 1 minus 0.1. 0.99 can be written as 1 minus 0.01, and 0.999 can be written as 1 minus 0.009. Am I right? है ना. So n terms we have to do the summation. So what do we get? We get 7 by 9. This 111 will add up to n, and 0.1, 0.01, 0.001, this will become an infinite GP. So the sum would be 0.1 upon 1 minus the common ratio. 0.01 upon 0.1 would be what? 0.1 only. है ना? So what do we get? We get 7 by 9 n minus 1 by 10, and this would be 9 by 10. है ना? 10 goes off the 1 by 9. So 7 by 9 into n minus 1 by 9. This is what I'll get. Okay? Yes, students? Yes, Giridhar? 0.001 what you're writing? Okay. So this is solved. Then we quickly come to harmonic progression. Then we'll go to questions. Okay? Quickly finish all this. Then harmonic progression. We'll do more questions on special sequences and series. We'll do question more on that. Okay? So a sequence A1, A2, A3, An of a non-zero is a harmonic progression if the reciprocals of the terms are in AP. Okay? The general term is given by this. No information about the summation of harmonic progression is given. Then we have a harmonic mean. What is a harmonic mean? So again, I'm going to give you 3 important points. Yeah, AGP and telescopic series will be doing Giridhar. So what do we have here? First point, harmonic mean between two numbers. Okay? So harmonic mean between two numbers x and y. What is that? That is 2xy upon x plus y. This is the harmonic mean between two numbers. Okay? And similarly, if we have ABC in HP, ABC are in HP, this implies 1 by A, 1 by B, 1 by C are in AP. So this would mean B is equal to 2AC upon A plus C. So if I compare this and this, then I realize that B is the harmonic mean between A and C. Okay? This is what we get. Right? This is the first point in harmonic mean. Second, harmonic mean between n numbers. The numbers are x1, x2, x3 and so on. So the harmonic mean is given by n upon 1 by x1 plus 1 by x2 plus 1 by x3 and so on till 1 by xn. Okay? This is the harmonic mean between n numbers. I hope you understand. Then the last is in the harmonic mean, last, it is the harmonic mean. The last point is inserting of n harmonic means between two given numbers. Inserting of n harmonic means between two given numbers. Okay? So we'll convert it into an AP and then we'll do two given numbers. That is A and B. So the harmonic means between A and B, let's say H1, H2, H3, these are the harmonic means. Okay? Hn and then B. So if after insertion of these numbers, this should become an HP. That's what it is. So the reciprocals are in AP. 1 by A, 1 by H1, 1 by H2. These are in AP. Okay. Now 1 by B is the n plus 2th term of the AP. That would be 1 by A plus n plus 1 common difference dA. From here I'll calculate the common difference. That would be A minus B, AB into n plus 1. That's what D I'll get. Okay? Yeah, we gonna go do questions better. Jatin, we'll be doing questions. Just let me finish the theory. Okay? It's a revision class, so we need to finish the theory. Okay? So D we get here. So what is H1? 1 by H1 would be 1 by A plus D. 1 by H2 would be 1 by A plus 2D and so on. Okay? 1 by Hn, the nth harmonic mean, it would be 1 by A plus Nd. And D you will take it from here. Okay? I hope you understand it. Now, if sum of reciprocal of n harmonic means between two numbers is n times the reciprocal of a single harmonic mean between them. So this is the relation we get between sum of reciprocal of n harmonic means, and I mean that has been converted into AP itself. Okay. Okay, relation between AM, GM and HM. Now here everybody, I would like to draw your attention. You have already, Bhavik Sharma, hello. So AM is greater than equal to GM is greater than equal to HM. Okay. And here before that, I want to also add quadratic mean. Okay, please listen. Tomorrow class also we'll be doing questions. We'll be practicing only questions, MCQs basically, Meenakshi, on sequence and series. The quadratic mean, suppose A and B you want to take arithmetic mean, so that would be A plus B by 2. Geometric mean would be AB and harmonic mean would be 2AB upon A plus B. And the quadratic mean I am writing, that is A square plus B square by 2 whole under root. That is quadratic mean. And the equality is, Avik, which class? Which class syllabus? This is quadratic mean between A and B. Okay, now we do a question. Let's say y is equal to x square plus 2 minus under root. Achha, the equality is valid when the numbers are equal. Equality is valid when A is equal to B. x4 plus 4 by x. Okay. Now x belongs to positive real numbers. Okay. Bhavik Sharma, it is not 11th class. This is JEE Mains class. Okay. And the topic is from 11th standard. X belongs to R plus. What is the maximum value of y I can get? Maximum y. Okay. Maximum y is equal to what? So all the students, you were waiting for the question. This is the question. Y is equal to x square plus 2 minus under root x4 plus 4 whole upon x. What is the maximum value of y I can get? You can use any method of your choice. You can use calculus if you wish to. You can do anything. Okay. Go ahead. Yes, students. What is y maximum we are going to get? So I hope, students, you are into the very best spirits to do the preparation for yourself. Anna? In your free time, I hope you're not wasting your time, and that's highly required. Huh? You see, this is the time, this is blessing in disguise, because you have got this lockdown. So because of that, the JEE Mains has been extended. But when it is a blessing in disguise, it is not only for you, it is for everyone. So the students who will make use of this opportunity will only come out happily. They will come out with flying colors in their exam. So please do make the most of the time which you are getting, because otherwise someone else who is participating in your race will go ahead. It's a long race. Okay. So Make the most of it. With your grit and determination, you will hitch your wagon to the star. So, anybody with an answer? No, no one is with the answer. I hope you guys are trying. Let me see. How is B at JEE Main's maths level? Same or less? B arch mains maths level. 3 is square root of 5. No, Prashant, this is not the answer. 3 minus the square root of 5. No. So we have y is equal to x square plus 2 minus x4 plus 4. I'll take x below it. I'll take x below it. Okay. Now, what is this? This term is x plus 2 by x. Am I right? And this x goes inside the under root sign. It will become x square. है ना? So x square plus 4 by x square. Am I right? है ना? This is what it will become. Ayush Kumar, BR J means 2. You mean to ask what was your question? Is B at JEE Main's maths level same or what? Yeah, it's approximately same only. I know, because as an architect also you'll require maths, so the maths level is same only. Okay. Now, I'm explaining, Prashant. Just have a patience. So what do we get here? We consider this as, let's say, x is alpha and 2 by x is beta. So what is written here? Here it is alpha plus beta. Here it is alpha square plus beta square. I want to find out the value of this maximum. है ना? When do I get maximum? Now, listen. We have quadratic mean greater than equal to arithmetic mean. Isn't that right? Now, quadratic mean between alpha and beta would be what? It would be alpha square plus beta square by 2. है ना? And arithmetic mean would be alpha plus beta by 2. Am I right or wrong? Okay. Then we have 0 alpha plus beta by 2 minus alpha square plus beta square by 2. Am I right? Now consider this, x is alpha by 2 and 2 by x is beta by 2. Okay, take it beta by 2. Then what this would entail? Tell me. This will be alpha square by 4, beta square by 4. X would be alpha square by 4. Okay. So if I get like this and I replace, that means the maximum value of here, the point here is, instead of using x is equal to alpha by 2 or beta by 2, because that would make a confusion. Okay. This is the maximum value we are trying to find. Now you have to realize that the maximum value of this right hand side is 0. Am I right or wrong? Tell me. The maximum value of this right hand side is 0 because this is always less than equal to 0. Okay? No, it's right only. The inequality is right only, beta. Ayush, quadratic mean is greater than equal to arithmetic mean is greater than equal to geometric mean is greater than equal to harmonic mean. Okay? Now listen, please listen. I'll prove it also that this is true. Okay, just wait. Now the maximum value happens to be 0. Okay? Now the maximum value of this expression is 0. So when do I get 0? When these terms are equal. है ना? The equality sign, didn't I tell you that when the terms are equal, then the equality sign exists. So 0 is obtained when alpha is equal to beta. Okay. Now consider this. Now here this term would be equal to this, then only x should be equal to 2 by x. Okay, then only we'll get the maximum value out of it. Okay, just hold on, listen. Forget about values of alpha and beta. I mean, here I'm getting an, if I divide it by 2, है ना? If I divide it by 2, I'll get the arithmetic mean of alpha and beta. Am I right? Array, if I divide it by 2, then what do I get? Arithmetic mean of this, and 2 would go inside with a 4. So this would become x plus 2 by x by 2. That's the arithmetic mean between x and 2 by x. And here you get x square plus 4 by x square by 4. Okay, that would mean the same thing. Now x by 2 you will consider as alpha, and 2 by x you will consider as beta. Okay, so now x should be equal to 2x, 2 by x, so x is equal to root 2. So at x equal to root 2 we get the maximum value of y. Okay, I'll make use of the other sheet. So at x equal to root 2 we are getting the maximum value. Okay, x equal to root 2. So when I put root 2, what I get? Y maximum, I'll get root 2 square plus 2, है ना? Minus x4. x4 would be 4. 4 plus 4 upon root 2. This is what I'll get. Okay? Yes, Shashi Tripathi, you're saying something? So what would be y maximum I'll get? I'll get 2 plus 2, 4 minus 2 root 2. Root 2. I'll multiply by root 2 and divide by root 2. So I'll get 2 root 2 minus 1, and that is the answer. That is the maximum value of y which I can obtain. Now I'll prove that quadratic mean is greater than equal to arithmetic mean. I'll prove this. Okay, minus 8 root 2, what's that? Okay, the quadratic mean is a square plus b square upon 2. That's what I'm saying. And arithmetic mean is a plus b by 2. Let's see whether it is greater than or not. Okay, now this somebody challenged me that this is not true, the inequality is opposite. So let's check. We do squaring both sides. A and b are considered as positive. So what do we get? A square plus b square by 2. And here what do I get? A square plus b square plus 2ab upon 4. Am I right? 2 and 2 vanishes. 2 is multiplied here, so I get 2a square plus 2b square is greater than equal to a square plus b square plus 2ab. है ना? What is this? This would be a square plus b square minus 2ab greater than equal to 0. Am I right? Now this would mean what? A minus b whole square is greater than equal to 0, which is always true. Am I right? And the equality sign exists when a is equal to b. Now you understand it? Okay, I hope this is understood by you guys. Okay, so that's how it is to be done. Now we come to, let's do another problem. Okay, let x, y be positive real numbers and m and n are positive integer. The maximum value of the expression. Let's do another question. What would be the maximum value of this expression? Okay, just go ahead. Meenakshi Sundaram, previous slide. Which slide you are talking of? The last one which I used? Okay, you can see it in the offline video, hai na? You can see it in the offline video. Okay, Meenakshi? So x, y be positive real numbers and m and n are positive integers. The maximum value of the expression. What do we get? Yes. Can I get an answer? So, since this is a theoretical class, so I'll take the liberty to explain you straight away. Now, listen that if A belongs to a positive real number, okay? Then A plus 1 by A, that is the number and its reciprocal, is always greater than or equal to 2. You understand this? A number and its reciprocal sum is always greater than or equal to 2. Why? Because this is from arithmetic mean greater than or equal to geometric mean, okay? So we have, if I solve it, I'll get a squared plus 1 greater than 2a, or this would mean a minus 1 whole square greater than or equal to 0. Okay? This is what it is. So if I write this expression as, if I divide the whole expression by xm and yn, so this would become 1 upon 1 by x raised to power m plus x raised to power m. Am I right? And this would be 1 by y raised to power m plus y raised to power m. Am I right? Now, you want to find the maximum value of the expression. Maximum value will be obtained when the denominator is minimum. Am I right or wrong? Denominator is minimum, and then you will get the fraction as maximum. So minimum value of this expression, minimum value is 2. X is positive, m is an integer, so x raised to power m is also positive. So the minimum value is 2, the minimum value is 2. So what is the maximum value which I get? 1 by 4. Am I right? Yeah. Yes, Ashit Shekhar, 1 by 4 is the right answer. Okay. I hope this is well received by you guys. Oh. This is well received by you guys, huh? So arithmetic geometric progression we'll progress to. Arithmetic geometric progression is the combination of arithmetic and geometric series. This series is formed by taking the product of the corresponding elements of arithmetic and geometric progression. So we have written a general AGP. A plus D, A plus 2D, A plus 3D is progressing as an AP, and 1R, R square, R cube is progressing as a GP. So what's the sum of a GP? Can somebody write me the sum of a GP, AGP? Sum of an AGP is sum to n terms. That's A upon 1 minus R, if I correctly remember, minus dr 1 minus r raised to power n minus 1 upon 1 minus r whole square. Then we have minus a plus n minus 1 d r raised to power n upon 1 minus r. This is the sum to, yes, I remember it. Wow. So Sn is this. Okay. So this is Sn. And S infinite, that is, if an infinite AGP is considered, we'll get a upon 1 minus r, and this would become 0, this would become 0, because r would be taken as, mod of r would be taken as less than 1, hai na? So what do we get? Minus dr upon 1 minus r whole square. That would be the sum to infinite GP. Okay. I hope this is okay with you guys. Now let's do one question on it, and then we'll learn the methods which are used for AGP. Sum of 1, 3, 7, 15, 31 to n terms. Okay, how do we do this? Yes, so we realize that the difference between 1 and 3, this is not an AGP, if you realize. I mean, this and each of the terms do not contain two terms. What's the difference between these two terms? 2. What's the difference between these two terms? 4. What's the difference between these two terms? 8. So that means the differences are in GP. Am I right or wrong? 2, 4, 8. And this is 16 if I'm not wrong. So 2, 4, 8 and 16. So how do we do this? It's a sort of a difference series. So Sn I'll write 1 plus 3 plus 7 plus 15 plus 31, and I keep on writing till n terms. N terms sum I have to find, so till an I'll write. Okay. Then again I'll write Sn. I'll start writing it from the second term, below the second term. 1, 3, 7, 15 and here it would be an minus 1, and then I have an. Okay, now I subtract it. When I subtract it, what do I get? SN gets cancelled, 0, and I get 1 plus 3 minus 1 is 2, 7 minus 3 is 4, 15 minus 7 is 8, and 31 minus 15 is 16. This way, an minus 1, whatever it comes, it is minus an. Okay? Now, 2, 4, 8, 16. Can somebody add it up? 1, 2, 4, 8, 16. These are n minus 1 terms. है ना? So if I add 1 to it, this will become an will be taken on the left hand side, and it would be 1 plus 2 plus 4 plus 8 plus 16. And how many terms are these? These are n terms now. Okay? 1, 2, 4, 8. I can do the summation. That is 1, first term, common ratio 2. Number of terms. What are the number of terms here? Tell me. N minus 1. GP, sum of n terms formula I am using, upon 2 minus 1. है ना? So what do I get? I get an is 2 raised to power n minus 1. Am I right? I can check this. If I write n is equal to 1, so that is 2 minus 1, 1. 2 square minus 1 is 3. 2 cube minus 1 is 7. 2 raised to power 4 minus 1 is 50. So this is what I get. Huh? I mean 2-3 questions more are there, beta, Jatin. We'll be doing few questions. Telescopic sum also we'll be doing. So 1 or 2 questions on telescopic sum. 2 questions I think on telescopic sums. Okay. So what do we have? We have an as 2 raised to power n minus 1. है ना? So this implies ar would be 2 raised to power r minus 1. So what is sum to n terms? Sum to n terms would be ar. R is equal to 1 to n. Okay. Yes, John Pandya, you are saying hello so many times. What is there? So summation 2 raised to power r minus 1. R is equal to 1 to n. So what is this? Summation 2r is separated. R is equal to 1 to n. And minus summation 1 is separated. R is equal to 1 to n. So 2r from 1 to n, what would be the sum? That would give me 2 raised to power n minus 1 upon 2 minus 1. Am I right? And summation of 1 from 1 to n will give minus n. That would be sum to n terms. So 2 minus 1 is 1 only. So this is 2 raised to power n plus 1 minus 2 minus n. That is the answer. Okay? Yes, Pandya, I am wonderful. I am fine. So this is what we get when we solve this. Let's go ahead. Question, the value of this is, I think this is comparatively easy, है ना? How do you do this? This can be written as 2 raised to power 1 by 2 square. 4 can be written as 2 square. So 2 square raised to power 1 by 8. Then I have 2 cube raised to power 1 by 16, and so on infinitely. So the powers would be added up. So 1 raised to power 2 square plus 2 upon 2 cube plus 3 upon 2 raised to power 4. 16 I can write it as 2 raised to power 4. So we realize that there is an infinite AGP in the numerator. Okay? Infinite AGP in the numerator. So this sum I need to find. How would I find out this sum? Please understand, then the formula which we have used for AGP, we have the first term of the GP as 1. So we'll have 2 here. 1 by 2 square would be taken common. So what is the first term? 1 plus 2 by 2. Then the third term would be 3 by 2 square, and the next term would be 4 by 2 cube, and so on infinitely. Okay. So thereafter what we'll do, we'll write 2 raised to power 1 by 2 square, that is 4. And I'll make use of the AGP formula. Infinite AGP formula was what? A, that is 1, upon 1 minus R, that is 1 minus 2, minus D. D is 1, R is half, dr upon 1 minus R whole square. That was the formula. So, what do we get? We get 2, 1 by 4, 1 minus 1 by 2 is 1 by 2, so 2 would come in the numerator, minus 1 by 4, 1 by 2, so 2 would come here, है ना? Something wrong I have done? That's coming out as 1. Huh? Seems bizarre. 2 raised to power 0. Why it can be 0? 1 by 2 square. I did some mistake, beta. 2, 3. So AP dr, A is 1, D is 1, R is 1 by 2. I did some mistake. What mistake I have done? Tell me. A upon 1 minus R minus dr upon 1 minus R square. Yes, it's coming 0 only. So that's 1. That would be 1, huh? That is wrong. It shouldn't come as 1. Why it would come as 1? I think I've done some mistake. Oh yes, here it is plus. Sorry, I wrote it wrong. In the previous slide as well. It is plus. Yes, please do the correction here, students. Plus dr. Yeah. Where I have given you the formula? I have given you the formula of AGP. Here. It is plus. Just I am doing the correction. It is plus here. Okay. Yes. Sorry guys. A slight mistake. It is plus here. Okay. A 1 minus R dr upon 1 minus R square. Here also it is plus. So please do the correction. So we come back to our where we were doing. So we get 2 plus 2, that is 4. So that is 1. 2 raised to power 1. Okay. Yes. Thank you, Jatin. No problem. So this is 2 raised to power 1. That is 2. Yeah, that's acceptable. That is 2. Okay. So 2 will get as an answer. Okay, students? Yes, that would be correct. So then we quickly have a look of summation of n. Summation of n is n into n plus 1 by 2. Sum of first square of natural numbers is n into n plus 1 into 2n plus 1 by 6. Sum of first square of natural numbers. And then sum of cube of natural numbers is sigma n whole square. Okay. Now let us do one more problem. What will be the sum of 1 into 2 into 4 into 2 into 4 into 8, 4 into 8 into 16 to n terms? So this is a special sequence. We have to find the sum. We have to find the nth term of this sequence. So we realize the nth term would contain 3 terms. So the first term is 1, 2, 4. So it's a GP. And the second term is 2, 4, 8. It's again a GP. And the third term is 4, 8 and 16. It's again a GP. So how do we get the sum, the nth term? Nth term here would be A R raised to power n minus 1. What would be this? First term is 2, common ratio is 2, and for 1 I'll get 1, for 2 I'll get 2, n minus 1. Am I right? And this would be 2 of square into 2 raised to power n minus 1. So if I multiply it, what do I get? I get 2 raised to power n minus 1. I get 2 raised to power n. I get 2 raised to power n plus 1. Am I right? So what do I get? I get 2 raised to power 3n, है ना? That is the nth term. So sum to n terms would be summation 2 raised to power 3r, r is equal to 1 to n, है ना? This would be it. So this is nothing but 2 raised to power 3 plus 2 raised to power 6 plus 2 raised to power 12 and so on. No, sorry, 9 and so on. So this is a GP with first term 8 and common ratio 2 cube, that is 8. Number of terms n minus 1 upon 8 minus 1. So what do we get? I think one question more. Yes, that is Tarun, that is based on telescopic sum. 8 by 7, 8 raised to power n minus 1. That's the answer. Okay, that's the last question. One more question. One more question to go. Okay, now we go to a telescopic sum question. 4 upon 1 into 2 into 3, 5 upon 2 into 3 into 4, 6 upon 3 into 4 into 5. How do we get this? So we write the general term of the sequence and then we'll try to reduce into partial fractions. Okay, so 4, 5, 6 numerator nth term I'm trying to find. This would be first term 4 plus n minus 1 d is 1 upon n into n plus 1 into n plus 2. Am I right? This would go 1, 2, 3. This would be n. What is this? So what is the nth term? I get n plus 3. है ना? And here I have n into n plus 1 into n plus 2. Am I right? Okay. Now what I'll do, I'll have to find the partial fraction of it. A by n plus b by n plus 1 plus c by n plus 2. That's how I'll do. Now a would be obtained when we put n is equal to 0 here, except in this. So I'll get a is equal to 3. When I'll put 0, I'll get 1 into 2, that is 2. A is equal to 3 by 2. B is equal to, I'll put minus 1 except in this. So minus 1 will fetch me 2, minus 1 and 1, that is minus 1. So B is minus 2. And C would be, so n is equal to minus 2 I'll put, except in this. So minus 2 it would be 1, minus 2 it would be minus 1, minus 2, that is 2. So C is equal to half. Okay. So what partial fraction, this nth term I have broken into partial fractions, that is 3 by 2n plus, sorry, minus 2 by n plus half n plus 2. Am I right? So now this telescopic sum method I am using. How? I'll write this Sn would be summation of an, summation of an, and I mean AR from R is equal to 1 to n. So I'll write first 1, 3 by 2, 1 by n I'll write, So 1 by n would be 1 plus 1 by 2, this summation I am doing, plus 1 by 3 and so on. Okay? Till what? Till it is 1 by n. Okay? Minus sum to n terms only I need to find. 2 by n. So 2 is taken outside. 1 I'll put. Then 1 by 2. Then 1 by 3. And so on 1 by n. Okay? Minus 2 by n plus 1. Meenakshi, you are saying minus 2 by n plus 1. No, B is... so that's what... n plus 1. You are right only. Thank you. Thank you, Meenakshi. Yes. Yeah, I'll give you a short explanation about telescopic method as well. So this would be till 1 by n and this would be 1 by n plus 1. Thanks, Meenakshi. And the next term would be 1 by 2, and n plus 2 I'll take, so it will start from, so it won't start from 1, it will start from 1 by 2, okay? When n is 1, so it would be 1 by 2. And this would start from 1 by 3, 1 by 4, and so on till 1 by n plus 1. Okay? Now, I realize that 3 by 2 and half becomes 2. So from 1 by 3 to 1 by n, everything gets cancelled. With 1 by 3 to 1 by n, everything gets cancelled. Okay? Because 3 by 2 into 1 by 3 to 1 by n, half into 1 by 3 to 1 by n adds up to 2. So 2 and minus 2 will gives you a 0. So what is left? We are left with 3 by 2 into, I'll make a space here because otherwise I'll lose the contact with the question. So I'll make use of the space here. So what is left? I'm left with 3 by 2, 1 plus 1 by 2, that is 3 by 2. And here what I'm left with? Minus 2 into half, that is minus 1. And 1 by n plus 1 is also there, minus 2 upon n plus 1. Okay? And here I get 1 by 2 into, from 1 by 3 to 1 by n, everything is 1. So we have 1 by n plus 1 and 1 by n plus 2 is left. This is what we are left with. So this is the sum which we are looking for. 2 and this becomes 9 by 4. So this is 9 by 4 minus 1. 9 by 4 minus 1 is what? 5 by 4. And you add, subtract this. So half of n plus 1 and minus 2 upon n plus 1. So finally we get an answer from here. So just a moment. 5 by 4 and we get minus 2n plus 1 and half n plus 1. Okay. So we get 5 by 4 minus 2 upon n plus 1 plus what was here? Half. 1 upon n plus 1 plus 1 upon n plus 2. Okay, this is what we'll get. So half n plus 1 and minus 2 n plus 1, I'll get 3 by 2 minus 3 by 2 minus 3 by 2 n plus 1, and here it is half n plus 2. Okay, of course I can take LCM and I can write in the form, I'll try to write in the form in which it is given in the choices. Okay, I hope this is understood. This would be the answer. Okay, yes. Now you were talking about that you were asking me to represent that how that works out, telescopic method. So I'll give you how it works out. Actually, telescopic method works out that you split the nth term into two parts. Okay, split the nth terms into 2 or 3 parts. So when you split into 2 or 3 parts, it should become some term in n minus some term in n minus 1. I mean, it should just, or n plus 1 and n. I hope you understand. Now it should split into this. So when you do sigma of this to find out the sum to n terms. So sigma tn minus 1 would mean t1 minus t0, I mean it starts from t2, okay, or maybe it is n plus 1. t1 t2 plus t2 t3. I mean when you put n is equal to 1 you get t1. When you put n is equal to 1 you get t2. So this is the first bracket which you'll get. This would be the second bracket which you'll get. The third bracket would be t3 minus t4 and so on. The last bracket would be tn minus tn plus 1. I hope you understand. So this way, Jatin, t2 t2 is cancelled, t3 t3 is cancelled, t4 t4 etc. is cancelled. Only the first term and the last term is left. And that would give you the sum to n terms. That's how it is taken. So that means you have to split the nth term into consecutive two terms. I hope you understand. For example, I give you a simplest case, 1 into 1 by 2 plus 1 upon 1 into 2 by 3 plus 1 upon 3 into 4. Okay, this way there is a summation. So what is the nth term? Nth term is 1 by n into n plus 1. This is what is the nth term. Okay, yes Jatin, welcome. So I split this as 1 by n minus 1 by n plus 1. Okay, then sum to n terms would be sigma an. So that would be sigma 1 by n minus 1 by n plus 1. So this would be, when I'll expand it, first 1 I'll put. So here it will become 1 by 2. When I put 2, it would become 1 by 2 minus 1 by 3. When I put 3, it would become 1 by 3 minus 1 by 4. And so on till 1 by n minus 1 by n plus 1. Okay, so here we realize half cancel, 1 by 3, 1 by 3 cancel. This all would be cancelled. What is left? 1 minus n plus 1. 1 minus 1 upon n plus 1. So this is n upon n plus 1. That's how we get the sum. And this is known as telescopic sum. Thank you, Meenakshi. Thank you. Thanks a lot for your appreciation. So students, we are ending the session as of now. I hope there is no doubt from your side. Hello? Is it okay? So tomorrow we'll be practicing on sequence and series. Tomorrow we'll be practicing on sequence series. Anybody with a doubt, please let me know. Okay, thank you. Thank you, Ashar Checker. Bye. Yes, you too take care, Jatin Raj. Bye-bye. Bye. Tarun, bye, beta. Bye. So, yes, students.